Welcome viewers, I'm Ranjit from Gate Online Training. I'm a R programmer. Hope you're enjoying the lecture series where we are learning R and SAS interchangeably. If you have not watched the previous video, please do check the description box, or please visit the channel and in the video sections. You can find the videos in the video sections. And if you have any questions or feedback, please post your feedback and questions in the comment section. And we are also providing paid courses, so for that we can visit our website greatonlinetraining.com. Okay, so far we learned how to import that file into R and SAS, right? Did some operations, we have sorted the data set, we have removed the duplicate, right? So in today's presentations we'll see some extension of the functionality. Okay, so let me move to the agenda first. Okay, so we'll first see the mathematical operators, and we'll see those operators based on a single value variable and also with a vector, and then at the end we'll see these mathematical operations on a data frame, right? And at the end we'll see how to calculate the change from baseline in R as well as in SAS. Okay, so let's jump to the R Studio and let me open that. Okay, so this is our studio. Let me first check the working directory. So for that, we'll have to write here get wd and parentheses, control enter. So it is in C drive. So as usual, so let me set into D drive because I have kept few data set which is required for this presentation. So set wd, and then after that we have to provide the location. Then here we have to set the location. Okay, and we have to also change this slash to convert that slash into forward slash. Okay, so let me run this. Okay, so let me check the working directory once again. Get wd and control enter. Okay, so if you see, working directory is set in a D drive. Perfect. So let me create one. Let me first introduce the operator. Right, there are a few operators, mathematical operators that we'll discuss today. So let me show you a few operators right here. Let me comment addition. The first is addition. Okay, so it is as usual, we have to use the plus sign for the subtraction, then the negative sign, then negative sign, then multiplication. Right, into comment. So for multiplication we have to use this asterisk symbol. Then after that we have division. For that we'll use forward slash. Okay, so and then we have to the operators remainder. For that we have percent and then percent. Okay, sorry, we have 2% for remainder. Okay, so now we have quotient. Okay, so now we have quotient. For quotient we have percent, then forward slash percent. Okay, so this is the symbol. Okay, and then we have the last power symbol, power operator. So for power we have to use this symbol. Okay, so let me create one vector here, two vector, right? So let me create num1. Okay, we'll save here few numbers here and we'll see. So let me create one element variable, and then we'll see this function with vector as well. Okay, so let me run first. Okay, num is created, num2 is created. Let me check one by one. So here if you see in the environment section, these two are created and these are the value 5 and 6. 5 is for num2 and 6 is for num1. Okay, so let me do this functionality one by one. Okay, so let me copy here, paste, and we'll see. Okay, so now I will use this operator one by one. Okay, so first write print, then num2 plus num1. Okay, let me print this. Okay, so 11, right? Let me do the subtraction here. So num2 minus num1. Okay, sorry, control enter, minus 1. Okay, so let me do the multiplication. So num2, then num1. Okay, let me run with control enter, then do the division. num2, then num1. Okay, 0.833, right? And let me calculate the remainder. Print. So we'll do num1, because num1 is bigger, right? We'll divide, otherwise we'll get in decimal, right? So num1 is bigger, that's why we will divide the smaller, we'll divide with the smaller number, right? So num2. Okay, so let me check. This is 1, right? Let me calculate the quotient here. So quotient, for quotient we have to use percent / percent, then num2. Okay, we have 1, because if you divide 6 by 5 we will get 1 quotient, right? Then we'll use the power function. So print, so num2, so num1 power num2. Okay, if we raise the power, 6 to the power 5 will get 7776, right? Perfect. So now we'll see with the vector. Let me change here the vector. Let me create one vector here, and then the vector is maybe will 2, 3, and 6. Okay, and here we'll create 2, 4, 3. Let me change 3 to 4 so that we can check. Okay, so let me run this. Perfect. Oh, we have to add here combine operator. Okay, let me create. Perfect. So let me run the first line. Okay, so this is the addition. So what it does, it add the number element wise. So whatever the operation will do, the R will do the operation element wise. The first element is added or subtracted or multiplied with the first element of the second vector, right? So this is the first vector, this is the second vector. So any operation what R does, it does with element wise, right? So if you see the addition one, so it has added 2 and then 2, so we'll get the first record as 4, right? Then 4 and then 4. Okay, so 4 plus 4 is 8, then 6 plus 3 is 9. Similar sort of expression we'll get for the rest of the operations, right? So let me run the subtraction part here. So element wise subtraction, so 2 minus 2 is 0, then 4 minus 4 is 0, then 6 minus 3. So it has done in both other way. So num2 minus num1, right? So it is 3 minus 6, so minus 3 will get. Okay, so similarly multiplication it does element wise. So num2, first element of num2 is 2, and then first element of num1 is 2. So 2 into 2 is 4, and 4 into 4 is 16, then 6 into 3 is 18, right? And similarly we'll do the division. So if you see, if we divide 2 by 2, so num2, the division is also on the element wise, right? So element wise division will get here. So if we divide 6, if we divide 3 by 6, so we'll get 0.5. Okay, let me check the remainder. So we'll see. So all are perfectly divisible number, right? So that's why we're getting remainder as 0. Okay, so if we change this number to 5, let me run this. Let me run the remainder here. We see, we'll get 2. So if we divide 5 by 3, we'll get 2 as a remainder. Let me check the quotient one. So if you see 1, 1, 1. Okay, and if we raise the power, so we'll get 4. So 2 raised to power 2, so it is 4 raised to 3 is 125. Okay, perfect. So now we'll see this operation on a data frame. Okay, so let me create one data frame here. Let me import here data frame. Let me import the file and we'll do the calculation over there, right? So let me first introduce the file. So data1, we'll create the data1 and then read.table. Okay, and here we'll do file dot choose. Okay, and we'll use the header of the dataset, right? So that's why we have to write here header is equal to true. Perfect. Let me run this. So it will open on pop-up window and we have to select the dataset. Suppose I wanted to open this data_1. Okay, so I have to select here. Okay, so it is loaded here. If you see, with 5 observation and 2 variable. Let me check that with function view. Okay, here we have to write data_data1. Okay, so this is the data set. We have 2 variable and there are few 5 rows here, right? So let me do this operation on the data. Okay, so let me comment this part. Let me copy above one. So let me copy as it is here. Oh, sorry. Let me copy here and we'll see the dataset operation on the dataset here. Okay, so the dataset is data, right? The data frame name is data1, right? So here we have to call with data1 and then $num1. Okay, let me check the first variable. Here we have to write call name, so it will show the caller data1. The first variable is num1, then second is num2. The same variable name I have kept, so that we no need to change here. Okay, so let me copy paste. Okay, here we have to extract in the same way. Okay, so let me run this. See, let me check the dataset here first. Show the dataset. So if we add num1, num2 and num1, right? So if you see the element wise addition, it has done, right? So 19 plus 120, 12 plus 2 14, then 17 plus 3 20, then 20 plus 4 24, then 17 plus 5 is 22, right? So perfect. So let me do the subtraction here. So similarly we have to place the data frame name first and then asterisk symbol as $sign, right? And here also we have to use in the same way. Asterisk sign, sorry. Okay, let me run this. Okay, so this is element by subtraction, right? So let me replace on the other operator, right? And we'll see at the end. Okay, let me do that. Let me run the multiplication once. Okay, so if I open this data set, so 19 multiplied by 1 is 19, 12 into 2, 12 to the 24, right? So if we multiply 17 by 3, we'll get 51. Similarly for other rows, right? So let me use the division operator here. So data1 and $sign. Similarly, we have to replace data1 and $sign. right? So let me check this division. So in the same way, so if we divide 19 by 1, so we'll get 19. If we divide 12 by 2, we'll get 6, right? If we divide 17 by 3, we'll get 5.66. Okay. Similarly for other numbers. Okay. So let me check the remainder calculation. Perfect. So same thing here. If you see, if we divide a num1 by num2, right? So we'll get 1 as a remainder for. Similarly, we get the value for the remainder as well, right? So similarly, we'll get the quotients and all, right? So we have to keep in mind that we have to replace with data frame name and then $sign to call the variable from a data frame, right? So if we wanted to call the variable from a data frame, we have to add here data frame name, then $sign, and then variable name, right? So it works in the same way. Okay, so that is fine. Perfect. Okay, so far so good. So we have checked all the operation on the data frame as well. Now we'll create variables into a data frame based on similar sort of operations, right? So let me do that. So the dataset I will use this the same dataset, but I'll create variable instead of checking the numbers, right? So here we have just added two variables and we have checked the values, right? So we saw all the variable values here, right, after adding. But now we'll create the variable into a data frame data1, right? So let me do that. So I will create, so we have to write data1 and then $sign. Suppose I write add, right, and create variable into the dataset. So similar, just copy this whole line, right here. Perfect. Now I'll run this. Okay, let me check the data1. Okay, if you see, the variable add is created. Similarly, we'll do for other variables as well, other operator. So similarly, we'll create other operators on a different variable and we'll see each operator one by one, right? So let me create here the subtraction. So data1, then $sign sub sub. Okay, then copy paste from the above operation. Okay, now we'll create data1 $sign multiplication, right? Data underscore division. We'll create the same thing. We'll replace here with / then data1, then $sign remainder. We'll replace the symbol here with double %, right? And data1, and here we'll use quotient Q, right? And we'll use the same function, same operation what we did earlier, right? So just copy and here we'll paste. Perfect. Now we'll create power. We'll use the symbol, this symbol. Okay, now we'll run one by one and see. Perfect. Now we'll see the data set. See, we have these many variables. Okay, so now I will move to SAS and we'll create the data set. We'll import the same file and we'll do the similar operation over there as well. Okay, so let me do that. So okay, so let me import. So prop import data file, out data 1 dbms dap, right? And then we'll write run. Let me change the data set here. Write the data path and data set. Data set is data underscore 1. Perfect. And then we have to write here the file extension .txt. Let me run this. Perfect. We have 5 observation here. Okay, so this is the data set that we called. There we have 2 variables, num1 and num2. The same data set we have used in our right. So perfect. Let me close this. Let me close this file as well. Okay, now we'll see the operation. Data, then data. Let me create the data 1. We'll set the data file data 1. Okay, and we'll do the same operation. Data add, then num2 plus num1. Okay, semicolon, then subtract num2 minus num1. Perfect. Then multiplication, so num2 and asterisk symbol num1. Okay, semicolon. Then division, num2 num1. Okay, now we'll do other function here, remainder. So we'll use mod function, right? So we'll use here mod function. Mod, and then we'll write here num2 and then comma num1, right? Perfect. And then we'll use the quotient. Okay, so for quotient floor function we'll use here, right? We'll write here num2 and num1 because num2 is bigger, right? So okay, and then we'll use the power function. Power equal to num2 then num1 double asterisk. Okay, let me change in the same way in R as we can compare the values as well, right? So this is num2. Let me split the screen. Okay, so the addition num2 plus num1 num2. Okay, so multiplication we have fine, division num2 and num1, then remainder num2 num1. Okay, perfect. The quotient, let me change here num2 and then num1. Okay, so we'll divide num2 by num1, right? And then power calculation will change in the same order, right? Num2 and num1. Perfect. So let me run R first. Okay, so this is the value we got, right? Let me run the SAS. So at the end we have to write run command. Okay, let me run with this submit key. Perfect. So let me compare the data here. Perfect. So if you see, let me open here as well. Perfect. So in case of subtraction, if you see the values 18, 10, 14, 16, 12, right? Because we have performed the same operation, right? So in division also, if you see 19, then so in division we have to go right. So in division, if you see 16, 19, then 19, then 6, then 5.66, then 5, then 3.4, right? And the remainder, if you see 0, 0, 2, 0, 2. Okay, so same here. The quotient, if you check, the quotient, we have 19, then 6, then 5, then 5, and then 3. Perfect. So, and power also we will get the same result. Perfect. Okay, and now I will import one another file and we'll do the change from baseline calculation, right? So let me import the file. So data, let me create the data too. Okay, so read dot table, perfect, file dot choose. Okay, and I will keep the variable of the data, right? But we have the variable, whatever variable we have, the variable name of the data set as it is, right? So that's why we have to write here true. Perfect. So let me open this data too. Okay, so let me check the data too. Perfect. So this is the first variable is baseline, then the second is post baseline, right? So now we'll do the change from baseline calculation, because in clinical domain we usually calculate that part. So the post baseline calculation is basically post baseline value minus baseline value, right? Okay, so let me create here. Let me create the data in the same data sets, data to 2. Then we'll create the variable name, change from baseline. Okay, so the variable name is data2 $sign post baseline, right? Then minus data2 $sign baseline, right? Perfect. So this is the value what we should get. Okay, so just let me check. So this is the value. So 9 minus 1, 8, then 12 minus 20 minus 8, and then 17 minus 31 is minus 14. Similarly for other, right? And there is another calculation, that is absolute change from baseline, right? So what we have to do here, just create data2 and create one variable, absolute change from baseline. Okay, same function we can use here, same chunk, right? And we write one function abs. So what it does, it changes the negative value into a positive. So it is basically absolute function, so it converts negative value into a positive one, right? So let me run this. Let me check the data set, data2. Perfect. If you see, let me open here. If you see, all negative minus 8 is converted into plus 8, minus 14 is converted into plus 14, and the rest is already positive. So no changes there, right? Okay, so let me calculate the change from baseline or absolute change from baseline in SAS as well. So let me import here the same file, right? So let me copy here. File name is data2. So I will change here data2 and here write data2. Okay, so now I will import this data2, right? Let me do that. Okay, so here we have data2, we have baseline values and post baseline value, right? So now we'll do the post baseline calculation, change from baseline, right? So change from baseline, and then we will write here post baseline minus baseline. Let me check the variable name. So SAS is not a case sensitive, so we can write small cases and uppercase. That is not a big issue, but variable name should be the same, right? Perfect. So, and let me calculate here ABS, absolute change from baseline. We'll use the same function ABS here. Okay, so I have to pass this data set here. data to 2. Let me run this. Okay, if you see, we received this, we got the same number what we have here. If you change from baseline value is 8 minus 8 is minus 14, 16 and 2. Then absolute change from baseline value is 8, then again 8 or 14 and 16 and then 2. Okay, so all the negative minus 8 is converted into plus 8, minus 14 is converted into plus 14. Okay, so far so good. Okay, so thank you everyone for your time. Hope you find this video useful. Please support us on YouTube, and also we are running paid courses. So for that you can check in the description box, or you can visit our website createonlinetraining.com. Okay, thank you everyone. Thank you for your time.